Hello, mic check. Am I audible?
Yeah,
Yeah, okay, we may start, please. Okay, so good evening to everyone gathered here. I am delighted to welcome you all to the second chapter of this edition's ProbeYond, the guest lecture series from the Department of EC that encourages students to think beyond, act beyond, and be beyond. Today's session brings us closer to the semiconductor industry again, but from a very different and highly futuristic perspective. We have with us a speaker who represents one of the world's leading names in chip design and advanced electronics. It is a privilege to host Mr. Abhishek Kumar, Senior Engineer at Qualcomm. Mr. Abhishek has been actively involved in developing next generation VLSI architectures and exploring the fast growing intersection of hardware design and agentic artificial intelligence. His work focuses on how modern AI driven approaches are transforming the way chips are built, optimized, and scaled. From architectural planning to design strategies and emerging opportunities, his expertise provides a rare inside view of where the semiconductor world is heading. Through this lecture, he will be guiding us through the future of VLSI, current industry trends, the rise of intelligent design systems, and the increasing role of engineers. Questions like this help us understand not only what technologies are changing, but also how we as students and future professionals can prepare ourselves for the challenges and possibilities ahead. I encourage all of you to stay engaged throughout the talk, ask thoughtful questions, and make the most out of the opportunity to learn directly from the someone deeply rooted in the industry. With great pleasure, I welcome Mr. Abhishek Kumar to begin today's seminar.
thanks very much for the introduction. Uh, do I need to switch on my camera or is it okay to continue? It's fine to continue, sir. It's fine, right? Yeah. Okay, I'll put this into presentation mode. So, a brief intro about myself. I have done my bachelor's and master's from IAC, primarily on modeling simulations. And after graduating from IAC, I have worked in the semiconductor industry for about 7 years. I started my career in 2005 since it's a semiconductor startup. I worked on compilers and then I was into the packet labs where I was involved in look at compute. File the patent on GPU architecture. Moving forward, if you want to follow me, you can use this link. So, okay, coming back to the agenda, we have two-part agenda. First is India's semiconductor mission, where we see how our country has is placed in terms of semiconductor and talk about what's the roadmap for the talent gap that we have, sector-wise demand and supply gap we see. It's required on chip design, system design. We'll also look into manufacturing sectors, foundries, assembly, testing, packing, and display. And we'll briefly talk about what is the R&D which is going on in India and across the globe. The second part of the talk will be on agentic AI, how this agentic AI is transforming the VLSI design. You know, so to start with, let's focus on the India's semiconductor mission. So the semiconductor industry is you can broadly divide into these subcategories like chip design, system design, foundries, assembly, testing, packing, marking, and display. And these categories broadly, diverge into two broad industrial domains: manufacturing and design. The manufacturing talent, they support for silicon foundries, assembly testing, marking, packing, and display fabrications. And the design talent is for chip design, system design. And what we have seen that in the coming 10 years, it will increase. Based on the historical data, the design has a good growth rate, around 15%, 10 to 15% for the past 15 years. And it is going to increase. And for the packing and assembly, foundry demands will also increase, but not as essential compared to design and system chip design, right? So here we can see there is a talent bridge coming from Semicon India, and we are seeing that in the design field. In this starts with 2022, we had around 1,25,000 talent pool, and in 2025 it will be around 1,80,000. And this projection is going to increase, coming to 2030, it's going to 3 lakhs and 4.5 lakhs. And this assumes that we have a 15% growth rate, and there is a new startup ecosystem which will invest, and this design space will increase. Similarly, for others, packing also, if you see from 1,000 to 3,000 to 15,000, it is substantial growth of 33%, and average numbers of employees will also increase, and it is going to double in the coming 10 years. Same for foundries. We see from 3,000, which is currently at 2025, 3,000 to 13,000, so 10x increase. Also in the display, it's going to increase. So it's a good thing for us is like in the Indian semiconductor roadmap is looking into this growth that going to happen based on the country's requirement of semiconductor. There will be a need for the talent pool, and the talent pool will be filled in design, not in packing, foundries, and displays. So I would like to point the stats that what's the demand and what we have. So futuristic demand, if you see, right, financial year 2025, number of people which are required to fill these industries. So we see that PhDs holders roughly around 4,000 PhDs, and BME students like 1,17,000. But this will degrade, but not that much because of the chip act that's going on globally. But moving forward, if you see, FY 27 and 2032, we see that there will be a substantial increase of number of PhD students. Like if you see from 3,000 to 15,000, 5x increase, and the B graduates, undergraduates, to fill this net demand, you see there is 2,45,000 euros would be created. So there is a huge demand in the country for semiconductor VLSI students across different degrees, PhD, B, ME, and diplomas. I will show you the stats of 2019 to 2022 of what were the UG students who were participating in electronics, electrical, and computer science. So if you see in total, you have like electronics students, 6 lakh students, and out of that, you see 1 lakh graduated. And electrical in the same way, around 3 lakhs 33,000 and 85,000 graduated. And of course, computer science, their majority will be higher, like it's around 9 lakhs, then 1 lakh 100,000 student pass. So we see that the number of students who are enrolling for the program versus number of students who are passing out is quite less. So between the demand that is required by the industry and the number of students who are passing out, right? So you see that there is a shortage, right? This is electronics, electrical, and computer science. And what about the highest degree students, the PG students, postgraduate students? So if you see that postgraduate students, they come from physics, electronics, electrical, computer science, and non-IT also. Why these people can contribute into this field? Because there is a gap which could not be fulfilled by this electronics and electrical students. So they also have physics, electronics, and students, but not at the UG level, but at the PG level. And if you see the ratio is almost same. Uh, this is not drawn to the scale. This is large scale, but still the trend is like that. Uh, there will be a substantial increase for PG students as well. When it comes to higher degree students, because they are focused mostly into one of the areas. So in the physics domain also, people who are doing microelectronics, they will be hired by industry. And if you see around 1,100 roughly in India, they pass out every year, and they can also fulfill this 15,000 or 5,000 that we have. And this is a trend which is ongoing. So this field, VLSI, is not just open for students who are doing electronics, electrical, computer science. It's also open for other students, physics students, and computer engineers and also IT professionals, right? So we can see that there is a supply demand gap. How to fulfill those? So students can plan accordingly. So again, this is from the industry, and the government is saying that okay, there is a breakdown for education. 80% of graduates are BTechs, 12% are master degrees, and 3% are PhD holders. And we are expecting that there will be 2 lakh jobs to be created this year, and this will also increase in the coming 5 years. You can see that this is the forecast that government is planning on the revenue that this industry will generate. See, we are in 2025, we are already generating around $3.35 billion revenue in VLSI and in hardware design around $3 billion, and embedded it's substantially more compared to VLSI. So how to start or where we are in terms of semiconductor. So I will just give you a rough, brief design flow of different aspects of chip design. And this is very essential that some students will fall into this category of architecture and modeling. Some will be falling into front-end design, some will be into the back-end and the verification part of it, right? So the design flow starts with high-level translation of high-level market requirements. So basically, there is a team which goes to the market, understands the needs of different consumers, customers, right? Accordingly, they will draw the architecture plan. The architecture plan is a high-level spec. So basically, it goes into this architecture modeling. So you have a specification. Based on the specification, you try to build models, functional models or cycle-based models. So you try to mimic the behavior of that. So this umbrella comes into the architecture model. So once this is done, you send your models for the logic design. So what logic designer does is it takes the high-level spec and to RTL, and the RTL is basically simulated and verified for functional and perf compliance by the DAG. And once this logic implementation is partitioning is done, then it goes to the PD engineer. PD engineer translates this RTL into gate level and transistor level fab implementations. So we'll talk about synthesis, how to place outs, physical layouts, and physical that. And then lastly, the testing inserts the requirement of synthesis functionality that checks for mutating the screen manufacturing defects. And all these engineering teams in the industry ISO, there are multiple teams, like one modeling team, another is the front end team, another is the back end team, and this physical design verification team, and these are big teams. They work in conjunction, collaborate to ensure that the functionality, performance, power, and other costs are met for the chip that we are giving out. And also, after this is done, there is a need for firmware development, which comes under embedded, and its job is to provide right level of abstraction to the OS so that whatever chip we have taped out is gonna used, and it is in that with the high level software which interacts with this hardware. So what is there for a VLSI engineering aspirant? So there is a huge scope for a VLSI aspirant. They can choose a domain of logic verification, physical design, or test, firmware development, even architecture modeling. And they can invest their career, and they can choose their courses accordingly, which I will talk later. How to plan. So this is the overall structure of a chip design, which is irrespective of any company, any SoC you are making. This is the process. This is followed across industry and as well as in academia. And different courses will be designed in your college to meet the requirements, so that once you go through the process, you will be understanding okay what all things to be done, right? So I'll talk about the course work and lab requirements. So basically, there is a prerequisite. You go with circuit analysis, logic design, and some software also. And then you have a chance. You can do a VLSI circuit design, logic part, SoC architecture, and then advanced hardware and the software solutions. And then after you have mastered this, you can go into specific domains like automotive, computers, communications, and these things you can plan. So basically, the teaching and evaluation should be done also in the same way. We try to solve more problems. Obviously, theoretical concepts are important, but more lab work, programming, and scripting language is required. And you can plan accordingly, that you can take this linear circuit analysis course and understand the basics, do the lab work, then go for a digital design, then semiconductor USS you can take. And from where I come from, we mostly focus on architecture, so you can focus on architecture as well. Then of course,
If
if
you
you
want
want
to
to
go
go
into
into
the
the
software
software
domain
domain
also,
also,
then
then
there
there
is
is
fundamentals of C++
fundamentals of C++
and
and
OS
OS
networking.
networking.
These
These
things
things
comes.
comes,
And
and
later
later
on,
on
when we see, when we go for machine learning approaches or agentic AI, this applied maths is also coming into picture, right? So I'll not go much into details of this. I have kept this in the PPT so that you can locate into it. It's based on your choice. If you want to go into physical design, focuses on these things. These courses, if you want to go into logic verification, focus on RTL design and SOC architecture. These courses and what are the blocks that you have, right? And yeah, so if you want to become more domain specific, then you can take domain specific courses also, embedded machine learning and this real time OS things. So you can spend your time on that and try to gain the knowledge from the specific courses and do it right. So we'll move into the next domain, which is like designing sector, the chip design and system design. So there are five categories or segments you can say where the chip design is happening. One is automotive, other is communication, enterprise level, industrial and personal electronics. So automotive, if you know all the automotive companies, they are also investing into chip design. Tesla, Tata, and other companies. Communication, Qualcomm is one of them. Enterprise, so AWS and other companies, they also focus. So you might have heard, like recently, 2 days back, they have released another CPU. And personal electronics, also they focus on system design. So from the semiconductor point of view, in the context of that, you can focus on like processor design, domain specific accelerated design. Then there's a focus on memory and storage system. So you can take these courses and try to develop this, right? If you're from the embedded background, there is a PCB. You can go with that, and a power delivery system, broad level signals also you can look into that, right? And then you can also try end-to-end debugging, because this is very important, debugging and software validation. So this comes under chip design and system design. And I have put some courses which you can take in your college. And apart from that, there is a lab component and get familiarity with that. So microcontrollers, is one of them. Then if you want to work with autos, kind of a real-time operating system, then these are the courses which are required, right? And if you want to go into the PCB level, then take board design, then IoT, things like that. You can not just from this EC department. If some other department is also offering these courses, try to take those courses. This will help you to come into the VLSI field, right? Lastly, there is a manufacturing sector. So manufacturing sector, we are, this is where India is lagging, that we don't have good fabs, So here we requires a range of skills, and there is a talent. Talent is required, but it's a complex chip design process, right? So you can plan accordingly. So you can take courses for operations and planning, right? And there is a manufacturing sector also you can try. But this is where not much electronics, but chemical engineers, material scientists, physicists. These people also come into this, right? And for automation, any degree holder, bachelor's, masters, but they should know this, this how to process control and things like that. So you can plan that. So if you want to work with that, then you will go to the silicon foundries. So like Intel fabs and all the TSMCs, these kind of work is being done in the manufacturing sector. So you can plan accordingly. For foundries and packing and testing, you see that compared to design, not substantial openings are there, but still they need people. Around 500. So around total, they need 1850 technicians. And there is a lag also that they can allow diploma degrees also, PhDs and masters are already there. So some of the things, the key limitation is capability to enter into the industry. So without significant skill, they won't allow you, because this is not just modeling. This is like producing wafers, and there is a very, high level of chance that you can make mistakes. So they won't allow mistakes. So at that level, so only Taiwan semiconductor, Samsung fabs, Intel, and other fabrication labs, they allow these people to work on that. And we have very small units which does these things, but at the R&D level, not at the industrial level, right? So coming to the display sector, so what they have done is Indian government, all the smartphones, tabs, laptops, and monitors, they have put it into the same category of display, but here also processors are used. So here I'm talking about Gen 6 and Gen 8.5 glasses, right? So you see that the number of units will substantially increase. We are here, so around 320 million units by 2025, and this projection is also uh, going to increase. It will cross around more than 500 million units. And just I'm talking about how this substrates and what level we call it, right? So at the silicon wafer, so Gen 2, Gen 3, Gen 5, Gen 6, and we are already here. And LCD we have reached. In India, we are lagging this, but there is a plan to set up this fabrication also, right? Uh, so there is also market demand, and for smartphones, TVs, and tablets, see that we saw that, in the case one at 2025 we are reaching around 800 million, and this will increase per month because people are buying more tablets, smartphones compared to laptops. So there's a huge market. So here also you can try and use your skills to get into this market. Right. Lastly, I'll talk about what is the status of research and development in this area. So to talk about R&D, there is a university labs, R&D centers, which can be private or public, and manufacturing fabs also. So the way they do it is there is a research labs which will do this research, and there is a flexibility because it's in academics you can do whatever you want. You can try more thing, explore more. You can build a POC and come up with a technology. Then it goes to development phase. That's where they'll try to do optimizations on whatever designs you have created, and then at the production level they do the testing, and then they'll do the demos. So if the demo succeeds, then they go for this scaling up and manufacturing. So I have given you some universities and R&D fabs and how they are operating. So here there is some university consortiums they have made, and they work in conjunction with industry. For example, this university consortium works with IBM. Yeah, of course, because Taiwan has TSMC, so it will work with this Taiwan university. So this is handle Asia. This is handling Asia, and this is handling our entire Europe. So IMEC is the research organization in Europe, which does a lot of R&D for entire semiconductor ecosystem, majority in Europe, and KV11 is in university. So you can also try to get into IMEC. I have some contacts over there. If you are interested, you can ping me, right? In India, yeah, of course, ISC has nano centers. So we have Center for Nanoscience. That's where we are doing fabrication, but not at that level. But we are missing this R&D at the commercial level, where the new fabs. So there is this supercomputing labs with there. We try to collaborate with that, right? So briefly, in 20 minutes, I have tried to cover this from the country's point of view, where we are, where, what we are looking into, and where we are headed, what all things is required to get into the industry. And so the second part is the agentic VLSI landscapes. I'll take a pause, and if you have any question at this moment, we can take that. Okay. Shall I go ahead? Any confirmation from anyone? Yes, sir. Okay. Okay, the second part is what's happening in the industry at the moment. So you all know that for the past 2 years, this agentic AI. So basically, I'm talking about this AI agents like ChatGPT. These kind of agents are used in VLSI now. So you all are student. By the time you'll graduate and you'll join industry, you'll see that these AI agents are in action in VLSI. So it's a good idea, not in the second year but in the final year, to take projects which uses agentic AI to do VLSI, and what all things you can do. So you can try automated. You can try automated design space exploration first one, right? How to come up with new architecture using agentic AI, and you can also look into the existing EDA tools that we have and how can we orchestrate that using agentic AI. And of course, this verification part is a huge thing. So excuse me, they are using agentic AI for verification and validation as well. In the later point of time, when it comes to foundry, the yield optimization is also using agentic AI. And I mentioned chip design and co-design with AI. So basically, you can use AI to design a new chip for AI. And lastly, you can do a supply chain management using agentic AI. And we'll briefly see all this, how it is done, right? So firstly, we'll talk about automated design space exploration, right? So when it comes to design a chip, you see there are millions of configurations. Right? Some are like what will be the power requirement, what is the area, what is performance. This is one of the problem statements in VLSI design. So the this is a question, and the question is how can we use an AI agent to solve these problems or at least get assistance, right? So AI agent can act as an intelligent agent, then that can do this thing autonomously, right? So what it can do. So since this involves millions of configuration exploration, AI agent can help us to minimize the search effort, right? So it can do this search design space exploration using some optimization techniques, and people are using reinforcement learning for that. And using that agent, you can prioritize your goals. And for example, that you can say that to AI agent, I have this many configuration, and I'm looking for a configuration where my leakage power is minimum within some time. So AI agents can help us to give you the configurations, and you can adapt it dynamically. So this is one of the space you can look into it, right? Second is excuse me, uh, sorry, how we can use these agents for EDA workflow orchestration, right? So what are the current challenges we have? So EDA tools, they are from either Cadence, Synopsys, and other vendors in Siemens, right? So there is a synthesis part, then the placement, routing, and timing closure. These are all complex tasks, and these require manual tuning. So AI agents can help us to orchestrate these things. They can use these tools. We can give these tools to the AI agents, or some part of it of the tools to the AI agent. For example, Synopsys, GC, Cadence, Incidence, Calibre. They can use these tools, and they can, what they can do is, okay, somebody has run it without AI agent, without using AI agent on these tools. They have the numbers, so we can feed in the data, this data to the AI agent that, okay, this was my previous run and I optimizes this tool for this parameter. Can you do it automatically? Then the AI agent will learn this and try to do a reasoning, because now AI agents are capable of doing reasoning. So they can reason about the constraint and rerun the step without human intervention. So if you feed in these things, now humans are not required, and AI agent will do the job for us. So this is the second part where intelligent agents are used for EDA workflow orchestration. Right. Third one is autonomous verification and validation. Right. So in the chip design process, functional verification consumes 70% of the time. So what we want? We want to generate test bench as fast as possible. We want coverage of test driven tests and formal proofs. So this can be done using AI agents. We can use some reasoning to identify corner cases and dynamically adjust the simulation strategies. Right? That for this stage test bench, we tried some other strategy which will help us for verification. Right? So agents can act not just running these things, but they can also monitor the convergence part of it, whether we are, whenever we are doing verification, it is converging or not. And additionally, if it's not converging, then it can trigger, because the test bench is also generated by AI agents, which can add additional test till the goal met. Okay, I'll take a pause for 30 seconds. I need some water. I'll come back. Yeah, I'm back. So this here we talked about verification and validation using AI agents, right? Okay, so we will also see how in the foundries it can be used for yield optimization, right? So what do we want? We want to improve our yield and it requires analyzing massive amount of web data which comes from the webs, right? And it needs adjusting of this, right? So AI agents can act as a closed loop agents that can monitor this data which is coming from the fabs, and it can predict the defects. Not only that, not also that, it can also do a correlation between the data and parameter uh, adjustment, right? So where it is used, it can do tune lithography, etching also it can do, and deposition parameters for better yields. This is where we can deploy these agents, right? Uh, Finally, then this chip design, co-design with AI. So basically, what do we want? We want to design accelerator using AI agents. These accelerators are basically they are the hardwares where the AI workload runs. So we want to improve that hardware where this AI agent runs, right? So here actually, because this is coming from the high level, AI agent needs to know that. So basically, human will come into picture that it needs to collaborate with the architect to propose a micro architecture changes. So once the micro architecture changes are uh, decided, then the AI agent can take it after that, right? So it can generate design techniques and then RTL variants, things like that, right? Lastly, supply chain. Not much into engineering, but the lastly, this part is also important. So, as a supply chain process manager or engineer, you can deploy this agent to predict what components there's a shortage of components and things like that, and it can optimize tape out schedules, things like that. So here, the agent will act as a planner across designs and manufacturing stage, right? To sum up, it is a landscape, right? So we have design, space exploration, verification, validation, and all this we can deploy an agent, right? So as a student, let's say you're in the final year, right? So you try to take one of the space and try to build your own agent, which does these things for you. And if it is meeting the criteria, right? And if you are able to complete your project, you can show it to the industry that from the day one you are ready. Since you are a VLSI student, you know all these things. You might have gone through all the courses and trainings. So this skill is known to you. The only thing is how to build intelligence to this AI agent, because this AI agent is dumb for now. Okay, what it can do is it can reduce the search space. So basically, if you prompt it right, it will take less time to give you the result compared to Google search or any search engine, right? So it has reduced your uh, search space, but you need to add your intelligence or whatever you have learned from these domains into the agent so that the agent acts like a design space exploration agent or verification agent or a yield optimization agent, right? So once these agents are ready, then it will interact with the tools that they have produced, the EDA tools, where these things were already implemented, right? Previously. So now the agent will learn from that, and this is what the agentic landscape looks like, and this is will be the future. In 2 years, coming 2 years, all the aspects of VLSI design will be using AI agents. You can say that 60 to 70% is already using in 2025. In 2026, 100% of the you know field will be using this VLSI design will be using AI agents, right? So to give you end-to-end workflow, so this design inputs architectural design. So first is your inputs and objectives, right? So you can give RTL, netlist, constraint, PPA goals, and things like that. Then AI agents, there is orchestration layer where can that agents will plan multi-step task. It will call the EDA tools, read the logs, reason about the failures, why the failure happened. It will iterate through the goals to improve PPA coverage or yield, whatever you have. And then agent shares memory also. So it maintains the warm-up time from the past projects and things like that. And then there is ADA engines and tools and adapters. So for example, synthesis tool, verifications, and lithography characterization. So agent will call these tools, and this agents can also use ML features. Run the database, telemetry data, whatever they have, try to bring it there, and there is a closed loop outcome. So there is a continuous improvement of this agent, and it can use reuse across design nodes and autonomously it can run and target until the target is met. So this is one of the flows. Another is what are the tools and which are already there. Let's say if you want to start this AI agent, want to build this AI agent for VLSI, what all things we already have. So I have given you two sets of list. One is your industrial proprietary, another is open source. So Cadence, Cerebrus, this tool uses agents and it is using reinforcement learning. And this is AI Studio is also using this agents, right? So again, other tools was Synopsys, DSO.ai. This is first autonomous AI application for chip design, right? It uses a reinforcement learning driven approach for space optimization across RTL to multi-level die inspections across distributed agents and learning. So RL is again used here also, right? Again, for Siemens EDA tools, they have this SolidView generative AI agent where it uses across custom analog workflows and a variant of it for verification and simulations. Siemens has also announced a plan for EDA agentic generative AI across different flows. So, for example, Siemens Aspira AI, Calibre AI version will also come, and it is coming. And again, ANSYS, Red Hawk, Pathfinders with NVIDIA Modulus landscape. So this uses physics also. Now, all these agents were using RL, but now this is ANSYS is using physics. So they are using physics informed AI agents to surrogate all the sign off that we get for thermal dissipation via AI integration, right? So these are your proprietary stuff, and there are open source also. So for example, AlphaChip, this is circuit training RL loop. This is open source framework by nature. So you can use this. You can go to GitHub, clone this, and then go for reinforcement learning based for planning methodology. It supports distributed training and integration. Google has also released this RL chip placement again, Nature 2021. Saying this is a very nice paper. You can look into it, right? This paper not just talks about reproducibility but also performance aspects. So go to nature.com and try to search for this Google RL chip placement, right? And again, if you want to use GPU accelerated platforms, there is a dream place. So basically it uses this placement like a training a neural network. So it's, if you know PyTorch or CUDA, this will help you to do these things in accelerated, right? Lastly, there is a dream GAN. So this is uses generative AI learning on top of dream place, whatever we have, with some commercial quality PPA wirelines and things like that. So you can go there and download. So these are few I have put, but there are many more. So you can see that whatever I have talked, right? Agentic AI, it's not just in theory, it's been implemented, and you have tools also. You can try these tools in your projects, right? Lastly, I'll talk about how does this agentic AI landscape looks like in the semiconductor design scale. So there is a phase zero where there is a guardrail and base planning. So you talk about synthesis, PNR, timing closures, things like that. Establish some governance, guardrail. What is the design rule? What will be the compliance, security audits, and things like that. Then infrastructure readiness, whether you have access to GPU, CPU cluster to run these things. If you have a cluster, what all schedulers are there, Slurm, PBS, or AWS Parallel Studio. And phase two is like agentic assisted. So once we have decided our baseline and guardrail, we go with agentic assisted pilots. So you can choose your agents accordingly. So there is a digital implementation cadence Cerebrus, this I told you, right? Synopsys and Solido, this NVIDIA's models also. So once this is done, then there is orchestration layer. Start with the simple agents, which reads reports, for example, congestion, slack, hotspot, process management, and reruns these things until the target are achieved. And once the targets are achieved, it will log you all the actions, right? Phase two is closed loop agents cross stages. So basically, each agent does not know what is happening in the other stage. So there is a timing and congestion agent sign off trade-offs. These things are there. You can read these things on NVIDIA's platform. And there is a memory usage also. So there is a warm-up model per IP family. Here's a benefit. So again, this I talked about AI. You can read about that. And then lastly, verification. So add an agent which will automatically generate the test bench, constraint, and things like that. So this takes around 12 to 20 weeks. And lastly, once these all the phases are done, then you go for scale to SOC and multiple die manufacturing. There also there are tools. Cerebrus AI Studio, then this Red Hawk we talked about, Digital Twins by NVIDIA Synopsys collaboration. You can read this in hot wires. And phase 4 is your agentic prioritization, workflow enablement, and this lastly for CAD engineers and PPA once this tape out is done. Right. So this is the landscape I've given you at scale. So it's around for 8 weeks or 12 weeks and 20 weeks. So this is how it is done in industry. Right. So with this, I'll close. Yeah. I'm open for questions. Was it too fast or any feedback?
No, no, sir. It was the perfect speed, and
Okay.
I hope everyone got what you were saying. I have just compiled some questions from students. Can I present them?
Yeah, yeah.
Ask them.
Yes.
Okay, so the first question was, uh, how do you the agentic AI which you talked about? So how do you see the agentic AI transforming the future of VLSI design? Like for over the next 10 years, how will the agentic AI change the designing of chips and all?
See, first thing I'll tell you, agents will not replace humans. Okay, they will be there, and humans will also be there, but humans ourselves to use agents. So it's like AI augmented, agenting augmented way, where you try to make agents as perfect as possible to do a task. Right. It's like fine tuning a neural network, something like that. So if you have a good skills of fine tuning a neural network, then that network is done. But it's not like that. Is the once you have trained a neural network, you don't have to do fine tuning. So over the next 10 years also, right? This I'm saying that this invention of this agentic AIs or the LLMs for that matter is such fundamental that no field, technical field, will be untouched by it. So you can't deny that. Okay, I will not use. I'm so good that I will not use this agentic AI. I will use my traditional approach for VLSI because then other people will be using it, and you can't lag behind. So that's one of the benefits. In 10 years down the line, you'll see that most will be automated. So basically, what will happen that you will have more harder problems because the smaller problems will be done by agents. Okay, like reading logs, parsing it, summarizing it, and things like that will be fully automated. Now your job will be to find out, okay, why this is the logs look like that, intelligence part of it. And if you have understood that, then you can put that logic into your agents. This is how this agentic AI will look like for VLSI. Yeah.
Okay, got it, sir. And next question was, as we are now doing BTech, what skills should we focus on now to work with AI in VLSI in the future?
See, as a EC student, my suggestion will be try to focus on the fundamentals. Learn fundamental as much as possible because these AI agents are nothing but they have been trained on uh, the data which is available. Right. So what happens for VLSI is like the data is not that cheaply available. It's not in public. Okay. So all the companies, right? Semiconductor companies, Intel, AMD, NVIDIA, hardware companies, they don't expose the data freely. For example, you have many image data. You can train your data, neural network or agents on that. But this data is very closed source. What semiconductor companies they have. So focus first on your fundamentals. Let's say 3 years or 3.5 years, you have mastered all the aspects which I mentioned right earlier of chip design, and you have mastered this. Then you think about, okay, because AI agents is already somebody has given it to you, right? What you have to do is just build a layer. It's kind of making an add-on onto a browser. So browser is given to you. You can prompt anything, you can search anything, but then you will add your layer of your intelligence. and make that AI agent for yourself. So you can build a model for chip design, something like that, right? So as a student, don't just skip all the fundamentals that okay because AI agents has come, I'll just focus on agentic AI and learn AI agents. That will be difficult. Your life will be difficult because what will happen, all the niche work will be done by these agents and your harder problems will come to you, and then you don't have the skill sets, you have not learned the fundamentals, you won't be able to solve it. So focus on fundamentals. Later point of time, then you go for agentic approach. This would be my suggestion.
Yeah. Okay, okay. Understood, sir. Uh, the next question was sorry, am I audible?
Yeah, you are audible. Someone is raising a hand.
Yeah, sorry.
Yeah, you can go ahead.
I think they can go. They can go ahead, I guess.
Yeah, Varshini, you can go ahead, Varshini.
Hello, am I audible now?
Yes, you are.
Uh, Thank you for the session, sir. It was really so interesting. I just have one doubt regarding the topic agentic AI. So, can I know how different it is from like regular training a regular model, like in the context of CCA? Once we train a model, our data set is going to be confined within the company CPI, and the model also will be deployed on the GPU, like our own device. So there's not going to be much effect on CCI. So can you explain the same context for agentic AI, sir?
See, you need to understand how this AI agent is different from the regular models that you are talking about. So is it like a ML model or a deep learning model, right? Something like
Yes,
that.
sir.
Yeah. So this agentic AI is also built on some model, right? So that's a transformer architecture, if you know that, right?
Yes, sir.
So those models which are different than this transformer architecture is not capable of doing reasoning. You have added reasoning now.
Mhm. Yes,
So the models which you are talking about, you have built a model. Let's say this design space exploration, right? So design space exploration you have given earlier. You give me what is the power, what is the clock frequency, what is the memory. You can build a model on top of that. Let's say power model, some kind of a regression you do and build a model for a neural network, but that's fixed. Okay, you can fine tune it, adjust the weights, but dynamically it won't be able to reason it out. It will just say, okay, given these parameters, this will be the result, classification or something like that. Okay, where it is like power hungry or memory hungry or a compute hungry, something like that. So this, because this architecture is such that it can reason, right? So it can do a lot of others advanced stuff which this traditional models won't be able to do it. So that's where this agentic AI will come into picture, because it can reason and you can argue with you that okay, your suggestion is this and I am as a AI agent, I have reasoned it out and this is my suggestion. So that level is not there into those deep learning models which are not based on this transform architecture. That's where this agentic AI will come into picture.
okay. Okay, so got it, sir.
Okay, fine.
If other participants want to ask any doubts, they can unmute and ask.
Okay, may I ask something?
Yeah.
Sir, can you please explain about the recruitment process? Is there a BTech candidates are more eligible other than MTech candidates from ECE background? Like, I want to explore these things at all.
Okay. See, you are in which year?
I am a final year BTech student, BTech ECE student.
Okay. See, in
Uh,
industry,
except skills. So these are the main things. I watched so much in LinkedIn sites, LinkedIn other job portals and eligibility criteria, job description too, and careers portal in websites too. So only MTech candidates are more in companies other than BTech candidates. So which will you prefer the most? Entry freshers such BTech is best or MTech is best?
Okay,
Okay,
I'll
I'll
tell
tell
you
you
how
how
this
this
VLSI or
VLSI
a
or a
hardware
hardware
domain is
domain is
different than
different
a
than a
software
software
domain.
domain.
Okay,
Okay,
and
and
why
why
you are
you are
saying
saying
that
that
MTechs are
MTechs are
more
more
preferred
preferred
than
than
BTechs,
BTechs,
right?
right?
You
You
saw in
saw in
LinkedIn.
LinkedIn.
So
So
Yeah.
even in
even in
my
my
organization
organization
or
or
in the
in the
research,
research,
forget
forget
about
about
BTechs, they
BTechs, they
don't
don't
take.
take.
The
The
reason
reason
is
is
this
this
is
is
pure
pure
engineering.
engineering.
So
So
it's
it's
more
more
engineering
engineering
driven
driven
and
and
more
more
skill
skill
set
set
and
and
more
more
knowledge is
knowledge is
required.
required.
So
So
what
what
happens at
happens at
BTech
BTech
level,
level,
you
you
all
all
have
have
uh,
uh,
surface
surface
level
level
information of
information of
all the
all the
subjects,
subjects,
right?
right?
And
And
you
you
can't
can't
make
make
mistakes. So
mistakes. So
what
what
they
they
prefer is
prefer
like
is like
let
let
the
the
student
student
go
go
for
for
MTech,
MTech,
specializes
specializes
on one
on
of the
one of the
topics,
topics,
gain
gain
some
some
more
more
exposure,
exposure,
and
and
then
then
enter
enter
into
into
VLSI.
VLSI.
The
The
reason
reason
being,
being,
you will
you will
make
make
less
less
mistakes
mistakes
because this
because
is
this is
not a
not a
software
software
job.
job.
You
You
see
see
what is
what is
happening with the
happening with the
software
software
industry,
industry,
right?
right?
Amazon
Amazon
laying
laying
off,
off,
Microsoft
Microsoft
laying
laying
off,
off,
other
other
companies are
companies are
also
also
laying
laying
off
off
because
because
now
now
this
this
agentic
agentic
AI
AI
landscape
landscape
has
has
taken
taken
over
over
all the
all the
works which
works
are
which are
very
very
easy to
easy to
do,
do,
or you
or
can
you can
say
say
niche
niche
work.
work.
Not
Not
many
many
people are
people are
doing,
doing,
few
few
people are
people are
doing,
doing,
and
and
they have
they have
trained it,
trained it,
so
so
it's
it's
going
going
in that
in that
direction.
direction.
As a
As a
VLSI
VLSI
student, I
student,
would
I would
suggest you
suggest you
to,
to,
if you
if you
have
have
not
not
gained
gained
the
the
industry,
industry,
it
it
does
does
not
not
matter
matter
whether you
whether
are a
you are a
EC
EC
student or a
student or a
PhD or
PhD
a
or a
BTech or
BTech or a
ME.
ME.
As
As
long as
long as
you have
you
a
have a
correct
correct
skill
skill
set,
set,
right,
right,
and you are
and you are
able to
able to
solve
solve
it,
it,
they'll
they'll
offer you.
offer you.
Okay, sir. Thank you so much, sir.
Yeah,
Yeah,
but the
but the
thing
thing
is,
is, you have to,
as a
as a
BTech
BTech
also,
also,
if you
if
have
you have
skills,
skills,
you'll
you
crack
crack
it.
it.
It does
Does
not
not
matter
matter
whether you have
whether you
MTech,
have tech,
but
but
we
we
prefer
prefer
MTechs in
MTechs in
VLSI
VLSI
because
because
they
they
will
will
have
have
might have
might have
gone
gone
through
through
very
very
rigorous
rigorous
process in
process in
MTech,
MTech,
and
and
they
they
will
will
make
make
less
less
mistake.
mistake.
It's
And it's
very
very
difficult to
difficult to
train
train
BTechs,
BTechs,
right?
right?
Once you
Once you
join,
join,
right,
right,
you will
you
go
will
through
go through
training.
training.
So
So
it's
it's
difficult to
difficult to
train.
train.
If you have
If you have
done
done
already
already
MTech,
MTech,
you have
you have
already
already
trained. From
trained.
the
From the
first day,
first
you
day,
can
you can
start
start
working
working
with
with
very
very
less,
less,
training.
training.
So
So
I would
I would
suggest
suggest
it's
it's
your
your
choice.
choice.
If you
If you
think
think
that
that
you
you
have
have
gone
gone
through
through
all the
all the
subjects
subjects
clearly and you
clearly
have
and you have
mastered it,
mastered
you
it,
can
you can
crack it,
crack
you
it,
can
you can
go ahead, go
go
ahead.
ahead.
But if you
But if you
think,
think,
okay, I
okay,
need
I
to
need to
specialize
specialize
on
on
this
this
subject,
subject,
go
go
for
for
masters
masters
and
and
then
then
come.
come.
Even for
Even for
me,
me,
I
I
completed my
completed my
masters and
masters
then
and then
came
came
into
into
industry.
industry.
Otherwise, you'll
Otherwise, you'll
get
get
not
not
good
good
jobs.
jobs.
Any
Any
jobs
jobs
they will
they
try
will
to
try
give
to
you,
give you,
right?
right?
So
So
it's up
it's
to
up to
you
you
and your
and your
situation.
situation.
You know,
You know,
plan
plan
accordingly.
accordingly.
Thank you, sir. Thank you for the kind response. Thank you so much.
Okay.
Okay.
Okay, thank you, sir.
Okay.
Okay.
Somebody is
Somebody is
asking,
asking,
can you
can you
please
please
say
say
about
about
internships?
internships?
Okay.
Okay.
So in
So in
research,
research,
we
we
prefer
prefer
masters.
masters.
Bachelor's
Bachelor's
also we
also we
prefer,
prefer,
but the
but the
thing is,
thing
it
is, it
won't
won't
be a
be a
3 months
3 months
internship.
internship.
Okay.
Okay.
It
It
would
would
be
be
1
1
year
year
or one
or
and a
one and a
half year
half year
internship.
internship.
Okay.
Okay.
That's the
That's the
thing.
thing.
The
The
reason
reason
being,
being,
okay,
okay,
skill
skill
set and
set and
criteria.
criteria.
Okay. The
Okay. The
reason
reason
being,
being,
in
in
three
three
months,
months,
we
we
won't be
won't
able
be
to
able
do
to do
much.
much.
And
And
if a
if a
company is
company is
investing
investing
in
in
you,
you,
they
they
want
want
return.
return.
So they
So they
want
want
longer
longer
relationship.
relationship.
So
So
6 months,
months,
and they
and they
expect you
expect you
once you
once
have
you have
trained, you
trained, you
join the
join the
company.
company.
As far
As
as
far as
skill
skill
set is
set is
concerned, it
concerned, it
depends
depends
on,
on
where you
where
are
you are
applying,
applying,
which
which
role you
role
are
you are
applying
applying
for,
for,
which
which
team you
team
are
you are
applying
applying
for.
for.
So
A
different
different
team
team
requires
requires
different
different
skill
skill
sets
sets
for
for
internship.
internship.
Okay.
Okay.
For
For
example, in
example, in
research,
research,
apart
apart
from
from
coding and
coding
your
and your
stuff,
stuff,
reading
reading research paper is important. Can you read a research paper in 1 week and come up with a new idea, things like that. So skill set wise, I would suggest check the JD, job description of the internship, check the team, and plan accordingly. And there are some general skill set which everyone will know, right? Debugging, coding, doing all those things. So these are the things. Most of the companies like Qualcomm internship for 30-year colleges will be hard. No, it's not like that. If you have skills and if they have offered you an internship, that means you are capable. You never think that from 30-year college it's hard. If a company is offering you an internship, let's say Qualcomm, if they have selected you, that means you are capable. You go there and show it. It's not like hard or easy. Many people are there from NIT. It's not a biased thing that a third year college will be hard. No, it's not like that. Pro tips for second year student to Qualcomm. See, it's too early for you to decide I want to go into Qualcomm. Okay. As a second year student, second year means you are in the third semester, right? Jo- what is Jyotisha? Right? Jyotisha Shri GS. Third semester student. Yeah. So third semester, how much you know? Barely know fundamental, and then you have just started, and then you are thinking of Qualcomm. So it's not a right time to think about Qualcomm, right? Maybe in the third year or fourth year, once you have clear idea of VLSI, then you plan, okay, Qualcomm or Intel, AMD, Nvidia, whatever, right? So it's too early to think about some tips to get into Qualcomm. No, there is no tips. Focus on your fundamentals, because if you think about getting into pro tips into Qualcomm, agent will replace you. So that's what my suggestion would be. Focus on fundamental, core fundamental VLSI. Try to understand that. If you are able to focus on that, you can come into Qualcomm, but not at the second year, fourth year. Anything else?
Sir,
Hmm?
sir, this is Ananya.
Okay.
With respect to detection of errors and handling bugs in chips, will this agentic AI function much better than humans in this field?
See, two things are there. One is how these agents have evolved. Okay. Another is uh, we call it expert. So let's say somebody who has worked in 5 years or 6 years for this debugging thing versus this AI agent which is newly has come. So it will act faster because it's a machine. It will act faster. It will give you result in, like, you prompt it, it will try to give you result in 1 minute. But the thing is, it not be reliable because that expert has all the knowledge. So vision is not there. What I'm saying is wisdom is not there. These agents, they don't have wisdom. You prompt them, they'll try to solve it. Whether it's correct or not correct, they don't bother. They'll just solve it. Okay, this is what you asked. This is what you'll get. From the debugging point of view and things like that, humans will be required, but at what level of debugging, right? So easy debugging, these agents will handle, but harder debugging, right, going beyond what the logs are saying. If I give you 10 timestamps of the logs, you can get the average, mean, median, mode, all these things. These agents can do it. You ask them, okay, what is the mean error? It will give you the mean error, standard deviation, things like that. It will do it for you. But how, what to infer is come from experts. So you have worked in this field, you know that if the mean error is this might be the failure or this might be the issue, right? So that's where humans will also be there, but as experienced people will not be replaced, right?
Yes.
So this is what will be.
Thank
Humans will work in conjunction with agents.
Okay, sir. Sir,
Okay.
sir,
Yeah.
this
Go
is
ahead.
Sir,
Go ahead. Go ahead.
this is Pradeep. Can I know anything? Can you please explain me the levels of job recruiting, like engineer from lead, senior lead engineer, like that things? Can you explain these levels and what are the things they accept from these levels?
Okay. 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 Fine. See, the levels, they vary from companies to companies. If you're talking about engineers, senior engineer, lead engineers in Qualcomm. So as an engineer, if they are freshers, they are treated as freshers. They are will give you'll be given a task. You'll take your time. You'll try to solve it. Right? Senior engineers will have some harder tasks, you know, and lead engineers will have much harder tasks, but they will also help senior engineers how to solve the task, right? And if you go beyond so that who have proposals and things like that, they
Uh, they have
they have
come
come
with
with
some
some
tag,
tag
and they
and
don't
they
want
don't
to do
want to do
research
research
because
because
age is
age is
also
also
like
like
that.
that.
Your
Your
20s,
20s,
22s,
22s,
they are
they are
still
still
not
not
clear
clear
what to
what to
do.
do.
In
In
R&D, they
R&D, they
can't
can't
waste
waste
money
money
on
on
such
such
things.
things.
So
So
we
we
prefer
prefer
masters
masters
who are
who are
clear
clear
that
that
okay,
okay,
in
in
bachelor's you
bachelor's you
have
have
all the
all the
options are
options are
open. I
open.
can
I
do
can do
this, I
this,
can
I
do
can do
that, I
that, I
can
can
go
go
there
there
also, I
also, I
can go
can go
there
there
also.
also.
But in
But in
master, it's
masters,
not
not
like
like
that.
that.
Once your
Once your
thesis is
thesis is
done,
done,
you
you
have
have
become,
become,
let's say
let's
you
say you
focus on
focus on
architecture, you
architecture,
are
you are
architecture
architecture
guys.
guys.
So
So
now
now
your
your
entire
entire
energy and
energy and
effort will
effort
go
will
into
go into
architecture.
architecture.
So
So
that's where
that's
they
where
will
they
go
will go
into
into
R&D,
R&D
and
and
they
they
will
will
be
be
given
given
those
those
tasks
tasks
to do
to do
research,
research,
right?
right?
Yeah, so
Yeah,
that's
so
the
that's the
requirement.
requirement.
Masters
Masters
they'll
they'll
take,
take,
bachelors they
bachelors
do
they do
take,
take,
but
but
after
after
10
10
years of
years of
experience or
experience or
8
8
years
years
of
of
experience,
experience,
once
once
we
we
have
have
understood
understood
things,
things,
then they
then they
take.
take.
Otherwise,
Otherwise,
bachelors
bachelors
they
they
don't
don't
allow
allow
into
into
R&D.
R&D.
PhDs,
PhDs,
masters,
masters,
and
and
bachelors with
bachelors
10
with 10
years of
years of
experience,
experience
they'll
they'll
take.
take.
Okay, sir. Thank you, sir.
Mm, Good evening, sir. One second, I'll take a question. Abhi Gupta is saying Qualcomm internship 6 month EC 4 year.
Yeah,
Yeah, what is the question, Abhi Gupta? Qualcomm internship 6 month EC 4 year. What is that?
is
Is
Abhi
Abhi
here?
here?
Abhi
Abhi
Gupta.
Gupta.
Okay,
Okay,
I'll
I'll
take
take
the
the
next
next
question.
question.
Hello,
Hello,
sir. I
sir.
am
I am
final
final
first
first
year
year
EC
EC
student. I
student.
am
I am
confused
confused
about
about
what
what
should I
should I
choose,
choose,
hardware,
hardware,
software
software
domain.
domain.
I'm
I'm
also
also eager to know
why
why
you
you
choose
choose
hardware
hardware
domain
domain
instead of
instead of
software.
software.
Okay,
Okay,
nice
nice
question.
question.
First year
First year
student, you
student,
are
you are
confused. You
confused.
are
You
a
are a
EC
EC
student,
student,
right?
right?
So
So,
can a
can a
EC
EC
student
student
surpass
surpass
all the
all the
hardware
hardware
things
things
and
and
go
go
into
into
software?
software?
RK,
RK,
who is
who
this
is this
guy?
guy?
RK.
RK.
It is
It is
showing
showing
RK
RK
in
in
my
my
screen.
screen.
So
So,
who is
who
this
is this
person?
person?
Can you
Can you
speak up?
speak up?
Can you
Can you
speak?
speak?
My
My
question
question
is,
is,
can
can
a
a
EC
EC
student
student
change
change it,
his
his
or
or
her
her
curriculum
curriculum,
go
go
into
into
software?
software?
Okay,
Okay, I'm also okay.
why I
Why I
choose? It's
choose?
not
It's
like
not like
I
that. I
choose
choose
hardware.
hardware.
It's
It's like
destiny.
destiny.
Destiny
Destiny
will
will
take
take
you
you
accordingly.
accordingly.
But
But
what I'm
what I'm
saying
saying
is,
is,
I
I
was a
was a
bachelor's and
bachelor's and
master's
master's
research
research
student.
student.
So
So
in
in
first
first
year, you
year, you
should
should
not be
not be
confused.
confused. You
You
should
should
be
be
like,
like,
okay,
okay,
these
these
are
are
the
the courses I have to
courses I
do.
have to do.
I'll do
I'll
it
do
and
it
go
and
into
go
the
into the
next year,
next year,
right?
right?
So
So
for me,
for
it
me,
was
it was
like
like
in the
in the
final year,
final
I
year, I
got to
got to
know
know
where I
where
should
I
go.
should go.
Okay,
Okay,
I
I
started
started
doing
doing
modeling,
modeling
simulations,
simulations
mostly,
mostly,
right?
right?
And
And
then
then
eventually, I
eventually I
ended
ended
up
up
in
in
HPC,
HPC,
high
high
performance
performance
computing,
computing,
parallel
parallel
programming,
programming,
and
and
things
things
like
like
that.
that.
So in
So in
first
first
year,
year,
you
you
should
should
not be
not be
confused.
confused.
If you
If
are
you are
confused,
confused,
then
then
leave
leave
your
your
education,
education,
right?
right?
No
No
point of
point of
studying.
studying.
In the
In the
first
first
year,
year,
right?
right?
You have
You have
just
just
graduated,
graduated,
you are
you are
into
into
engineering,
engineering,
and
and
then
then
you are
you are
saying
saying
you
you
are
are
first
first
year
year
EC
EC
student, and
student, and
EC
EC
student
student is
saying
saying
trying to
trying
go
to
into
go into
software. You
software. You
can
can
go.
go.
I'm
I'm
not
not
denying
denying
that you
that you
can't
can't
go.
go.
But
But
thing
the
is,
thing is,
first year
first
you
year you
should not
should
be
not be
confused
confused
because there
because
is
there
no
is no
options.
options.
All the
All the
courses are
courses are
given to
given
you.
to
You
you.
have
You
to
have to
complete it.
complete it.
Maybe
Maybe
later
later
on,
on,
once you
once you
go
go
to
to
the
the
next
next
year
year
or
or
some
some
other
other
year,
year,
you'll
you'll
have
have
option
option
to
to
take
take
other
other
courses.
courses.
First year,
First
there
year,
should
there
not
should
be
not
any
be any
confusion.
confusion.
Focus
Focus
on
on
what
what
is
is
there
there
in your
in your
curriculum,
curriculum,
right?
right?
RK?
RK?
Okay.
Okay.
Bhavya,
Bhavya, how can we follow trends in VLSI?
there are
There
some
are some
channels you
channels
can
you can
follow.
follow
Those
those
channels,
channels.
hot
Hot
chips
Chips
is one
is
of
one of
them.
them.
You
You
can
can
look
look
into
into
online.
online.
There are
There are
channels
channels
in the
in the
current
current
trends in
trends in
VLSI. You
VLSI. You
can
can
search.
search. research, and you'll get some channels. You can subscribe to those. There are some magazines also, uh, and whatever I have given you is the Semicon India. Try to follow that where countries headed, right? Things like that. Okay, now there is one guy who was talking. I told him to stop. You can ask the question.
Good evening, sir. I am Sarthak. I am a third final year student.
Yeah.
Sir, can you tell me or suggest me few projects in VLSI front end domain
Front end domain.
and how to choose the projects in the front end domain?
Okay, basically logic implementation, chip part testing, and design testing, things like that, right? Mm-hmm. So
So
what you
what
can
you
do
can do
is
is
first
first
try
try
to
to see
see across. Oh,
your
your interest
interest
is
is
also
also
important.
important, right?
Try
Try
to
to
see
see
across
across
your
your
whether do you
whether
want
do
to
you
do
want to do
GPU,
GPU,
CPU,
CPU,
memories,
and
and
things
things
like
like
that,
that,
and
and
then
then
try to
try
see
to
the
see the
architectures,
architectures,
micro
micro
architectures
architectures
for
of
different
different
companies,
companies, and
and
then
choose
choose
that
that
I
I
will
will
go
go
with
with
the
the
front
front
end
end
design
design
of
of
that
that
particular
particular
thing
thing
into your
into your
projects.
projects.
Okay,
Okay,
because
because
I
I
am
am
mostly
mostly
into
into
simulators
simulators
and
and
cycle
cycle
accurate
accurate
simulators,
simulators,
but I'm
but I'm
not
not
into
into
this
this
chip
chip
partitioning
partitioning
and
and
this
this
TFT
TFT
logic
logic
implementation.
implementation.
But
But
my
my
suggestion
suggestion
would
would
be
be
try to
try to
see the
see the
current
current
trends of
trends
the
of the
architectures.
architectures.
Look at
Look at
Intel's
Intel's
architectures.
architectures.
AMD is
AMD is
open
open
source, so
source,
you'll
so
get
you'll
it
get it
easily,
easily,
and
and
then
then
try to
try to
look
look
at
at
NVIDIA's
NVIDIA's
micro
micro
architecture
architecture
for
for
GPU
GPU
and
and
CPU.
CPU.
And if
And
you
if
are
you are
into
into
networking,
networking,
then
then
there
there
are
are
other
other
companies
companies,
Broadcom,
Broadcom,
NVIDIA
NVIDIA
Slingshot,
Slingshot.
Slingshot
Slingshot
is
is
there,
there,
InfiniBand,
InfiniBand,
things
things
like
like
that.
that.
And
And
then
then
try to
try to
go
go
with
with
this
this
front
front
end
end
design
design
space
space
of
of
that
that
particular
particular
thing,
thing,
right?
right?
Okay.
Okay, sir.
Okay.
Okay.
Anything
Anything
else?
else?
Okay.
Okay.
If
If
not,
not,
then
then we can close.
I
I
think
think
I think all the questions are over now. I think we can conclude. And as we conclude this insightful seminar, it is my honor to present the vote of thanks. Our deepest appreciation goes to Mr. Abhishek Kumar for joining us today and sharing such a rich and forward looking perspective on the world of VLSI. Sir, your explanation of current trends, evolving architectures, and the growing influence of agentic AI in chip design has given all of us a clearer understanding of the direction in which the semiconductor industry is moving. Your experience at Qualcomm and the clarity with which you approached complex ideas have been truly valuable. Sessions like this open new pathways for students who wish to step into the core engineering domain. Your guidance has surely encouraged many to explore advanced technologies, build stronger fundamentals, and aspire to contribute to this rapidly progressing field. We extend our sincere thanks to our coordinators and volunteers for planning and managing this event with dedication. And of course, a heartfelt thank you to every participant for your enthusiasm, questions, and presence, which added life to today's session. Once again, we express our warm gratitude to Mr. Abhishek Kumar for taking the time to be with us and for enriching ProbeYond with his expertise. We hope to welcome you again in the future, sir. Thank you all and have
Thank
Thank
a
you.
wonderful evening ahead.
Thanks a lot.
Thanks a
Thanks a
lot,
lot,
guys,
guys.
and
And
take
take
care.
care.
Bye
Bye
bye.
bye.
Bye, sir. Thanks, sir.